Okay, hello. I think we start our broadcast. So today we will talk about disaster recovery. It's very often happens that we start to think it after something happened, not before. But of course, more important data or more important services or more users you have, for you, this topic become more valuable. So let's start. Let's start from actually understanding what for us will be disaster. And a disaster for us will be an event that partly or completely disturbs the operation of one or more application. And disaster normally requires human intervention to fail over to secondary copies of application in order to maintain their functionality. And there are four biggest categories which we can categorize the disaster. So first one is human errors. So it's actions that lead into a security breach, such as inadvertent misconfiguration of the software or a database. Second one could be a malicious attack. So it's unauthorized actions that affect a victim system, such as denial of service or ransomware attack. Third one is natural disasters. So it's some environment factors that cause the system fail, such as quakes or floods, for example. And the fourth one is a technical failure. So it's when hardware or facility such as power failure or network connectivity failure. So let's go a little bit about why we need disaster recovery. And because based on why we need it, we can create an appropriate plan, because it can be different from one situation to other situation. And first one is direct and indirect financial loss. It means that the impact of direct financial loss is mostly relevant for applications that are critical for any revenue generation process. For example, external facing IT systems that are provided for customers for a fee, or internal IT systems that process data relevant for revenue generation. Indirect financial loss includes, for example, customers switching to a competing product, and the cost of work need to resume normal operation after the disaster is over. Second group that I separated is reputational damage. So in addition to financial loss, downtime caused by unexpected incidents can significantly harm a company reputation. A short recovery period aided by a sister recovery solution can help avoid can help to avoid the damage to the corporate image. And the third one is failure to abide by compliance standards. So multiple compliance standards, including system and organization controls, the payment card industry, data security standard, and health insurance, portability, and HIPAA requires a disaster recovery plan. And some standards even add very specific requirements. For example, minimal physical distance between the source site and the disaster recovery site. And let's check about common factors and challenges. So there are several factors to consider when planning your response to a specific disaster. So first one is unexpected duration of the disaster. So how soon will be the application recover and how likely is the disaster to resolve on its own? Second is the size of impact. So which applications are affected and to what extent of their functionality impaired. First one is geographic impact. So maybe regional, national, continental, or global. And fourth is tolerance of downtime. So how significant is the impact of the application, not function? Both the nature and the disaster and the geographic impact is important when considering your disaster recovery strategy. So for example, you can mitigate a local flooding issue causing a data center outage by employing a multi-IZ strategy, since it would not affect more than one availability zone. However, an attack on production data would require you to invoke a disaster recovery strategy that fails over to backup data in another AWS region. And AWS well-architectured framework help you to understand the pros and cons of a decision you make when building system in the cloud. And here you need to pay attention that you have a different responsibility between AWS, which take part of responsibility about disaster recovery, and you as owner of the cloud space. So the 6 pillars of the framework allow you to learn architectural best practice for designing and operating reliable, secure, efficient, cost-effective, and sustainable systems. So by using AWS Well Architecture tool available at no charge in the AWS Management Console, you can review your workload against the best practice by answering a set of questions for each pillar. Here I want to show you a little bit about the responsibility difference. It's very easy to find in the internet this image or something similar. Because it shows actually what is came to the customer to you and what is AWS. So as you see, hardware and services like compute, storage, database, networking, and global infrastructure like region, availability zone, edge location, it's on AWS. And such architecture, networking, quotas, continuous testing of critical infrastructure, this is came to your shoulders. Business impact analysis should quantity the business impact of description to your workload. It should identify the impact of the internal and external customers of not being able to use your workloads and the effects that not on your business. What else I want to point here is maybe about disaster recovery and availability. So disaster recovery can be compared to availability, which is another important component of your resiliency strategy. And here you can see example how to general schema how to represent it. This approach is often referred to a nines, where 999% availability target is referred to an 3 nines. So for your workload, it may be easier to count successful and failed requests instead of using a time-based approach. And disaster recovery focused on disaster events, whatever availability focused on more common disruption of smaller scale, such as component failures, network issues, software bugs, and loss spikes. The objective of disaster recovery is business continuity, where availability concerns maximizing the time that a workload is available to perform its intended business functionality. Both should be part of your resiliency strategy. And let's look a little bit about this abbreviation. So we have like first two is disaster recovery. First is RTO, which means recovery time objective, and RPO, it's mean recovery point objective. So recovery time objective is the maximum acceptable delay between the interruption of the service and restoration of the service. This objective determines what is considered as acceptable time window when service is unavailable and is defined by the organization. And recovery point of objection, which you see as PRO on the image, is the maximum acceptable amount of time since the last data recovery point. This objective determines what is considered as acceptable loss of data between the last recovery point and the interruption of service and is defined by the organization. Disaster recovery is, I would say, different in the cloud. So AWS Cloud includes the following advantages. Let me check. Do I have it? Yeah, I have it in the slide. So let's go a little bit deep into details about how work in the cloud with disaster recovery. So advantages of AWS is firstly is recover quickly from disaster with a reduced complexity. Simple and repeatable testing allow you to test more easy and more frequently. Fourth one is lower management overhead, decreases operational budget, and opportunities to automate decrease changes of errors and improve recovery time. Yeah. So for a disaster event based on description or loss of one physical data center, implementing a highly available workload into multiple available zones within a single AWS region help mitigate against nature and technical disasters. So continuous backup of data within this single region can reduce the risk to human threats such as error or unauthorized activities that could result in data loss. So data recovery option in the cloud could be like broadly categorized into 4 approaches, ranging from the low cost and low complexity of making backups to more complex strategies using multiple active regions. And actually, these 4 items you can check on the slide. So as you see, blue one is like lower probability of cases, less cost, restore like backups, provision of all AWL resources after events is more easiest and will take less money, and multi-site active how to say later part, it will be more costly. It's zero downtime, near zero database loss, and mission critical services. So it doesn't mean that what is more cost, it's like the difference between these 4 items is not too high. So anyway, like it will be available for users as long as possible. Like as I said, AWS guarantee 999% of availability, but it's really depend on sensitivity of the data. So in most cases, like the simplest one, backup and restore will be enough for you. Okay, so let's go one by one through them. So let's first check and backup and restore. So backup and restore is a suitable approach for mitigation against that data loss or corruption. This approach can be used to mitigate against a regional disaster by replication data on other AWS region, or to mitigate lack of redundancy for workloads deployed to a single availability zone. So as you see on the slide, you can have one availability zone, you will make a copy for other, and if something happens with one availability zone, your data will be saved and you will very quickly go to the normal operations that you have. And it still changes that something happened with both availability zone, but of course the chance is quite low. So AWS services which support backup. So let's talk about a little bit about it. You can use, sorry, I think I have it here. Yeah, you can use services which actually support it. And here you can find this list. So it's AWS databases, actually, if I'm not wrong, all the databases, and EC2 instances. I don't see it in the list. It's on the second list. Yeah. So on the first one is you can see backup with a point-in-time recovery is available through the following services. And a second one is AWS Backup provides a centralized location to configure, schedule, and monitor AWS backup capacities. And here you can see that like EC2 instance here, also DynamoDB in the both cases, storage gateway volume, and FSX. So you can see details in the screen. Next one, let's check a pilot-like architecture. So with the pilot-like approach, you replicate your data from one region to another and provision a copy of your core workload infrastructure. So a pilot-like approach minimizes the ongoing cost of discovery recovery by minimizing the active resources, and simplifies recovery at the time of a disaster because of core infrastructure required are all in the place. And this one you can see in as one of the examples you can see in the slide. Next one is the list is AWS Elastic Discovery. AWS Elastic Disaster Recovery. So it's continuously replicates server-hosted application and server-hosted databases from any source into AWS using block-level replication of the underlying services. And the last one, no, not the last one. But let's go to the next one. Next one is warm standby. So warm standby approach is involve ensuring that there is a scaled down but fully functional copy of your production environment in another region. So very similar to first approach, but this one is much faster because you don't recover service by service, you recover full environments. And next one, the most expensive, is multi-site active. So you can run your workload simultaneously in multiple regions as part of the multi-site active or not standby active passive strategy. So multi-site active services traffic from all regions to which it is deployed, whereas hot standby service traffic only from single region, and the other regions are only used for disaster recovery. With a multi-site active approach, users are able to access your workload in any of the region in which it's deployed. Actually, that's why it's one of the most expensive solution. So also, like few words that AWS have health dashboard, provide information about health events that can affect your account. So the information is present in two ways: a dashboard that show recent and upcoming events organized by category, and full events logs that show all events from the past 90 days. It can help you to get information about current situation or current status information, or subscribe to an RSS feed to be notified of interruption to each individual service. If you are experience in real time operational issue with one of the services that is not in service healthcare dashboard, so you can always create support request. I never seen the situation, but AWS gives this option. Next one is about testing disaster recovery, because it's good that we implemented, but without actually having any issue, you will not understand does it work or no, or how much time will it take to do the action. So you need some testing. A pattern to avoid developing recovery paths that are rarely executed. So, for example, you might have a secondary data store that is used for read-only queries. So when you write to a data store and the primary fails, you might want to fail over the secondary data store. If you don't frequently test this failover, you might find that your assumption about the capabilities of the secondary data store are incorrect. The capacity of the secondary, which might have been sufficient when you last tested, might not longer be able to tolerate the load under this scenario, or service quotas in the secondary region might not be sufficient. And if make a conclusion, so customers are responsible for the availability of the application in the cloud. It's important to define what disaster is and to have the disaster recovery plan that reflects the definition and the impact it may have on the business outcome. Actually, that's why we're doing it. And the three main conclusion points, which I think I can make. It's first is create a recovery time objective and recovery point objective based on impact analytic and risk assessments, and then choose the appropriate architecture to mitigate against disasters. Ensure the detection of disaster is possible and timely. It is vital to know when objectives are at risk. And ensure you have a plan and validate the plan with testing. We have checked four main, I would say, strategies that you can use in AWS, and based on your budget and how sensitive data you store and how important for you to have delay, you can select one of them. And just as note that disaster recovery plans that have not been validated risk not be implemented due to lack of confidence or failure to meet disaster recovery objectives. Yeah, this is what I want to discuss today. Hope it was useful, or at least you start thinking about are you ready for if something happened with your service or with your architecture. Please follow our group and me in the LinkedIn. And if you have any topic that will be interesting for you, I will be glad to dive deep in it and maybe talk about it next time. Yeah, I think have a good evening. Thank you, everybody.